Hello students, today I am here to do last revision before your O-level exam. That's revision exercise term 3. So first few questions in part 1, short questions. Make sure that you do within 2 minutes. We'll take the first one. Solve the following inequality and represent the solutions on a number line. So take the equation 2x plus 5 less than or equal to 15. So what you do? You take 5 to the other side. You get 15 minus 5, 10. Then x is 10 divided by 2, 5. So nothing happens to the inequality because you divided by a positive integer. So x less than or equal to 5. So how we can represent this on number line? You draw the number line and write down several numbers 0, 1, 2, 3, 4, 5, 6 and here minus 1. And this is equals to 5 as well. So we mark with a solid circle 5 and then this is less than or equal to 5. So we draw an arrow towards left side. So when you can draw like this. So x less than or equal to 5. Question number 2. Express the shaded region in the Venn diagram using set notation. So look at carefully. P, Q, R, 3 sets are there. So when you take Q and R, what can you see about this? So Q and R, this part is shaded. So if it's separately, you can clearly identify what's this region. Q dash intersects with R. So that's the set notation. Question number 3. The area of the square drawn on the hypotenuse of a right angle isosceles triangle is 64. So this is an isosceles triangle, means this length is equal to this length. We'll put A. The square drawn on the hypotenuse right angle triangle, this is the area is given 64 square centimeters. Find the area of the square drawn on one of the other side. So they are asking A squared. What's the A squared value? Now we need to find out what's this length to figure out the area. So use Pythagoras theorem. A squared plus A squared, you get, we'll put x or something here, x squared, 2a squared is equal to x squared. Now here x is there, but we know area is 64. That means x into x is 64. So x squared is 64. So we can write this one is 2a squared is 64 divided by 2. You get a squared is 32. So we need area of the square drawn on one side. That means a square. So what's the area? This is square centimeter. So this is the answer. Question number 4. You have given 2 matrices. Multiplication is there. So we'll do multiplication. Minus 3, 2, 0, minus 5. P2 equals minus 5 Q. So what you do? 2 times 2 with 2 times 1. What's the resulting matrix? You get 2 times 1. Minus 3 times P. Minus 3P. 2 times 2 plus 4. This one 0 with P, 0. Minus 5 times 2, minus 10. That's equal to minus 5 and Q. You can equate. So First one you can do minus 3p plus 4 is equal to minus 5. Solve this equation. Take 4 to the other side. You get minus 9 is equal to minus 3p. Divide by minus 3. You get 3. Other one straight away I can equate minus 10 equals q. So q equals minus 10. Question number 5. The tangents drawn to the circle with center O at the points A, B, C and D which lie on the circle meet the points P, Q, R and S as shown in the figure. If PQ plus SR is equal to 20, find the perimeter of the quadrilateral PQRS. What do you know about the tangents drawn to the circle from a point outside? The lengths are equal. So this length is equal to this one, this is equal to this one here and this one here. So what can you write about PQ? I can write PQ is PB plus BQ plus SR. SR I can write SD plus DR. That's equal to 20. Now I want to multiply this by 2. What happens? I want to multiply this whole thing by 2. This is 40. So we'll see what you are getting. 2PB plus 2BQ plus 2SD plus 2DR. What's that? 2PB. That means these two lengths. 2BQ means these two lengths because these are equal. 2SD means these two. So what's the perimeter? Basically this means the perimeter of the quadrilateral. That's equal to 40 centimeters. Question number 6. A and B are two events of a random experiment such that PA equals 0.4, PA union B is 0.7. If A and B are independent, find the value of PB. Independent means what's the situation? Intersection, we can write PAN into PB. That's the property of independent events. So remember that. Now we'll apply the equation formula for union. A union B is probability of A plus probability of B minus the intersection. A union B is given 0.7. PA 0.4. PB we don't know. We have to find out. Then I can write this one PA intersection B using this formula. PA means 0.4. 0.4 times PB. Now subtract this one, you can take it to this side. 0.7 minus 0.4. Here 1. Nothing means 1 minus 0.4. You get 0.6 PB, probability of B. Then 0.7 minus 0.4 is 0.3. Here you get 0.6. So what's PB? Probability of B is equal to 0.3 over 0.6 multiplied by 10. Both numerator and the denominator, you get 3 over 6 or half. So probability of B equals half. Question number 7. In the circle with center O shown in the figure, COD is 70 degrees and CBA is 100 degrees. Find the magnitude of ODA, this x value. Now we see this is a cyclic quadrilateral and this is 100. If this is 70, we can find out this angle. These two lengths are equal. Radii of the circle. OC is equal to OD radii. Then we can find out one angle here. What's that angle? 180 minus 70 divided by 2. I'll take this one. That's equal to ODC. 180 minus 70 is 110. Divided by 2, I get 55 degrees. So this is 55 and this is x. What you know about opposite angles of a cyclic quadrilateral? That's add up to 180. So B angle plus D angle is 180. Opposite angles of a cyclic quadrilateral. B angle is 100, D angle is 55 plus x. Now find x. 100 plus 55, 155. Take it to the other side. X is equal to 180 minus 155. 5, 5, 10. 1 remaining 6, 2. So x is 25 degrees. Question number 8. ABCG and FCD in the figure are squares. If AC squared is 12, CE squared is 6. Find the area of the whole figure. So we need to find out the sides. So this is a square, put A here and we'll put B here because all sides are equal. Now we need to find out the area. So what you need? We need A squared and B squared. A squared plus B squared is the question. When you take ABC triangle, we can use Pythagoras theorem. A squared plus A squared, 2A squared is 12 squared. 144, 2A squared. Divide by 2, you get 72. Look at the next triangle, CDE. B squared plus B squared, 2B squared is equal to 6 squared. That's 36. So divide by 2, you get B squared. Now just add these two. So we need A squared plus B squared, 72 plus 18. You get 90 square centimeters. Question number 9. The triangle ABC and ECD in the figure are right angle triangles. Find the area of the whole figure. How can we find out the area of a triangle? This one we can do. But here we need this side and this side to find out the area. Base times height divided by 2. So first we'll find out AC length. Pythagoras theorem. AC squared is 6 squared plus 8 squared. 6 squared is 36, 8 squared 64. You get 100 and AC equals square root of 100, that's 10 centimeters. So what's EC then? EC becomes half of it. 10 divided by 2, 5 centimeters. Now we know this is 5, this is 13. You can find out CD. So what is CD squared according to Pythagoras theorem? CD squared is equal to 13 squared minus 5 squared. 169 minus 25. So when you subtract, you get 144. Take the square root. You get 12 centimeters. Now we can find out the area. Area of ABC triangle, half times base 8 times height 6. You get 24. Triangle CDE, half times EC. EC is now 5 and CD we found that's 12. 6 times 5, 30. So the total area is equal to 24 plus 30, 54 square centimeters. Question number 10. Write down the matrix minus 2a. Minus 2a means you multiply all the elements by minus 2. Multiply minus 2 times minus 2, 2. Minus 2 times minus 1, 2. Minus 2 times 2, minus 4. Minus 2 times minus 2, plus 4. So remember, multiply all the elements by the number. 11th one. The tangents drawn from the point A to the circle in the figure are AB and AC. The tangents drawn to the circle at the point Q meets AB and AC at P and R respectively if the perimeter of the triangle APR is 18. Find the length of AB. You are asked to find this length. So only information given is APR. The perimeter is 18. We know AB is equal to AC. The length of the two tangents are equal. And if we can show this is equal to this one, so when you take the two triangles, we know two lengths are equal, two tangent lengths are equal. AB equals AC. Information given about the perimeter of the APR triangle. So what's the perimeter? AP plus PR plus AR is equal to 18 centimeters given. I can write AP as AB minus PB. PR I can write as it is. What is AR? AR I can write AC minus CR. Now I can write instead of AC, that's AB. So these two I can write AB plus AB, 2AB, and PR, I can write PR using these two, PQ plus QR. Then how can I write this one? This one I wrote AC, this is minus CR. Now, we know according to the tangents, these are equal. This length is equal to this one is equal to, this one is equal to this one. So, BP equals PQ, QR equals RC. So, I can write instead of PQ as BP. Then QR I can write as CR. Now what happens? CR get cancelled out, BP get cancelled out. 2AB equals 18. So what's AB length? 18 divided by 2, that's 9 centimeters. Question number 12. Write down the number of figure suitable for the blank space. The circumcenter of the triangle lies on a side of the triangle in triangles of the form. So, when it's right angle triangle, the circumcenter lies on the hypotenuse. So, which one is suitable? Part 2. The circumcenter of the triangle lies in the exterior of the triangle, in the triangle of the form. So, when it's obtuse angle, the circumcenter lies outside the triangle. So, that's 3. The circumcenter of the triangle lies in the interior of the triangle when it's an acute angle. So, this is acute, that's 1. Question number 13. Find the values of x and y in the given equiangular triangles. So, equiangular triangles means angles are the same. So, we can write similar triangles. Those are similar triangles. So, we can write ABC triangle and PQR triangles are similar. Why? It mentions equiangular. Then the corresponding ratios are proportional. So, we can write 3/6 is same as x/10 is same as 5/y. Now, we can take separately these two ratios and these two ratios. So, we will take these two. 3 times 1, 3 times 2. Cross multiply, you can find x. So, 10 divided by 2, you are getting 5 as the x value. What's y? We can take these two. 3/6 is equal to 5/y. 3 times 1, 3 times 2. Now, cross multiply, y equals 10. So, here we get x equals 5 and y equals 10. Question number 14. Represent in the integral solutions of the inequality. 4x plus 3 greater than or equal to 8. So, we will take 3 to the other side. So, 4x becomes 8 minus 3, that's 5. So x is greater than or equal to 5 over 4. So what's the value of 5 over 4? 1 and 1/4. 1 and 1/4. So when you draw the number line 0, 1, 2, 3, 4 like that, greater than. So 1 and 1/4 is in between 1 and 2. So somewhere here. So we'll put, this is the point. Greater than. Greater than, this means any number towards right side of that. But they are asking integral solutions. Integral solutions means only the integer values. So how can we mark the number line? We can draw the number line as we have to mark only the integer value. So greater than 1.25 or 1 and 1/4, I can mark 2, 3, 4 like that. So towards right hand side. Question number 15. Write down the coordinates of the turning point of the graph of the function x squared plus 5x plus 9 without drawing the graph. So how can we identify the turning point? If we can rearrange this to a square term. Completing square method you need. What's the method? Take the second term, divide by 2 and square it. You get 25 over 4. So you need to add 25 over 4, and in order to get no difference, you subtract the same value. Now these three I can write down the square term. Square root of x squared is x. Square root of this is 5 over 2. This is plus. So you get plus here. Now find the common denominator, 4. So you get 9 times 4, 36 over 4 minus 25 over 4. So x plus 5 over 2 squared plus 36 minus 25, you get 11 over 4. Now we can identify the turning point. So how we identify the turning point? This and this. Here, if this is plus, the turning point is minus, and here you get the same value here. So the coordinates of the turning point is minus 5 over 2, 11 over 4. You can simplify if you want and write down 4 times 2, 8, 2 and 3/4. Part 2, question number 1. ABC is 90 degrees in the right angle triangle ABC. So the B angle is 90 degrees. If P is the midpoint of side BC, this is equal to this one, then show that 4 times AP squared minus AB squared is equal to BC squared. So we need AP squared and AB squared. So we'll connect AP squared and we'll find out AP squared first. What is AP squared? AP squared is AB squared plus BP squared. What is BP? BP is half of BC. Because these two are equal. Then you get AB squared plus BC squared over 4 is AP squared. Now look at the equation. You need to multiply everything by 4. 4AP squared is equal to 4AB squared plus BC squared. Now take this one to the other side. You get 4AP squared minus AB squared is equal to BC squared. That's the first part. If Q is the midpoint of side AB, now Q is here. These two lengths are equal. Then show that 4CQ squared minus BC squared is AB squared. I'll connect CQ. How can I write CQ? CQ squared is equal to QB squared plus BC squared using Pythagoras theorem. Again, for QB I can write half AB. AB over 2 squared BC squared. Now expand it. AB squared over 4 plus BC squared is equal to CQ squared. Now multiply everything by 4. 4CQ AB squared plus 4BC squared. Now take it to this side. You get 4CQ squared minus BC squared is equal to AB squared. That's the second part. Using the results obtained in 1 and 2, deduce that this one. Now we'll add these two. 1 plus 2. What happens when you add 1 plus 2? You get 4AP squared minus 4AB squared is equal to, here this side we are adding 4CQ squared minus 4BC squared. This side you get BC squared plus AB squared. Now what is BC squared plus AB squared? What you get? AC squared. Instead of this one I can write AC squared. AP squared plus, look at this one, AP squared and CQ squared is there. So you can't do anything. This one, take minus 4 out. Again you get AB squared plus BC squared. AB squared plus BC squared, we can write this one as AC squared. So minus 4AC squared here, 4, I can take it out, AP squared plus CQ squared is equal to AC squared. You get same term AC squared, take it to the other side. AC squared plus 4AC squared, you get 5 AC squared. So AP squared plus CQ squared is equal to 5 AC squared. That's part 3. Now part 4, show using the results obtained in part 3 above that when the above triangle is an isosceles triangle, isosceles right angle triangle, then AP to QP is equal to root 5 to root 2. AC to, it says AP to PQ. Now you have to use that answer. If it's when the above triangle is an isosceles right angle triangle. So what it means, this length and these lengths are equal. So you can take as CQ is same as AP. When it's equal, you get the same length. So it says isosceles means you can write down BC is equal to AB. Then all these lengths are equal. AQ is equal to QB, that's equal to BP, that's equal to PC, because midpoints. So when it happens, this length is equal to this length, so AP squared is same as CQ squared. So AP equals CQ. Now, when you apply here, what happens? Both are same. So AP squared CQ squared means 2AP squared. I can write 4 times 2AP squared is equal to 5AC squared. 4 times 2, 8AP squared is equal to 5AC squared. What's AP squared? That's okay. So we need AC squared. Now what is, from this one, what is AP squared over AC squared? AP squared over AC squared is equal to 5 over 8. We'll keep this one as 1. Now look at the diagram. P is the midpoint of BC, Q is the midpoint of AB. So what can you say about PQ? What can you say about this PQ and AC? What's the relationship? According to midpoint theorem, we can write AC is equal to half. AC is double of PQ, or PQ is half of AC. We need QP, so we'll include, instead of AC, double of PQ. So we'll plug here double of PQ. So AP squared, instead of AC squared, I can write double of QP whole thing squared is equal to 5 over 8. Now simplify this. AP squared over 4QP squared is equal to 5 over 8. So what is AP squared over QP squared? AP squared over QP squared is equal to 4 times 5, 20 over 8. Then simplify 4 times 2, 4 times 5. So when you take the square root, both sides, AP to QP is root 5 to root 2. So you are asked to find out AP to QP as a ratio. So what's the ratio? AP to QP is, I can write down AP to QP is equal to root 5 to root 2. Question number 2. ABCD is a rectangle. Using the trigonometric tables, find the length of AE. So you asked to find AE. We know that to this angle, this is opposite and this is adjacent. So what's the suitable ratio? Suitable ratio is tan. So TOA, TOA, TOA is tan. Tan ratio, tan of 35 degrees, 36 minutes is equal to AE over 30. So what is AE? Multiplied by 30, the tan 35, 36 value. So we'll look at the tan value. Tan 35, 36. 35, 30. 35, 30 is this value. 6 is 26. So we need to add 26 to 0.7133. Add 26. 7159. So 0.7159. Multiply by 30. Put 0 and multiply by 3. 3 times 9, 27. 3 times 5, 15 plus 2, 17. 1 remaining. 3 times 1, 3 plus 1, 4. And 3 times 7, 21. And 4 places we have to keep. The answer is 21.477. So this is in centimeters. So we can write AE is equal to 21.477 centimeters. Find then calculate the perimeter of the trapezium BCDE. BCDE, this length we know. This length we can find out by subtracting these two, but we need to find out BE as well. So again use trig ratios to find out BE. So what's the appropriate ratio to find BE? You can use cos ratio. Cos ratio or sine ratio, doesn't matter as long as you are using either this or this. Now we'll see which one is easy. If you take this one, hypotenuse is unknown. And here if you take this one, then again hypotenuse is unknown. So that means you have to divide by this number. If you take this one, we'll take cosine rule with 35, 36. According to AEB triangle, I can write cos 35, 36 is equal to 30 divided by BE. So BE equals 30 divided by cos 35, 36. So convert to sine. We subtract from 90, 89, 60, subtract 35, 36. 54, 24. So I can convert to sine and write sine 54 degrees and 24 minutes. Now we can refer the table for sine. Sine 54. Which table? We need second table. Second table 54. We need 54, 24. 54, 20 and 4 is 7. So add 7, 81, 31. 81, 31, that's 0 point. Now refer log tables and find out the answer here. So we'll do it here. 30, 0. Look at the log table and find out the answer. 4771. The characteristic is 1. Then 81, 31. What's 81, 31? 9102. What's the characteristic there? Bar 1. Now what you have to do? Subtract, because this is division. So you get 9, 6, 6, 5, and here you get 1. Now refer anti-log value for 5669 and find out the answer. What you get? 3689. This is 1 is their characteristic. So the answer is 36.89. So BE equals 36.89. Is it centimeters? Yes, centimeters. Now we found BE. Now we can find out the perimeter. So what's the perimeter of the trapezium? Perimeter of BCDE perimeter is 40 plus CD equals 30 plus ED. ED is 40 minus AE. 40 minus AE. AE we found 21.477. 21.477. And what's the other side? BE. BE we found 36.89. Now add all together. What's the value? 40, 40, 40, 80, 80 plus 30, 110. So you get 110 plus 3689. You get 146.89 and subtract 21.477. Here you get 8 minus 4, 4, 5 and 2, 1. So add all together, you get 7 plus 3, 10, 1 remaining. 125.413. So I'll round it to 2 decimal places. So the perimeter is 125.41 centimeters. Part B. So you have given another question. So we'll do it in the next page. Part B. The 3 cities A, B and C are located such that city B is 50 kilometers from city A on a bearing of 40 degrees from city A. So take city A is here on a bearing of 40 degrees. So B is here 50 kilometers from city A. So B is here. And city C is directly to the north of city A. That means city C is here, north side, and the bearing of C from B is 270. What is 270 bearing from here? That means a horizontal line. So this is horizontal line. So C is here. Draw a suitable sketch and mark the above information in it. So this is first part. Part 2, find the distance from city A to city C. City A to city C means you are asked to find AC length. So what's the suitable ratio? If you are taking this one, this angle, this is adjacent and hypotenuse. But when you take this angle, that's sine. So which one is easy? cos you have to convert to sine and do it. So we'll do with 50 degrees. So this is 50, 90 minus 40. Now we'll use the ratio sine 50 is equal to AC over 50. So what is AC? 50 times sine 50. Now refer the table and find out sine 50. Sine 50 is 0.7660. 0.7660. So multiply by 50 now. Put 0 and multiply by 5. 5 times 0, 0. 5 times 6, 30. 3 zeros. 5 times 6, 30. Plus 3, 33. 3 remaining. 5 times 7, 35. Plus 3, 38. 4 zeros you have to, 4 decimal places you have to keep. So AC is 38.3 kilometers. So AC is 38.3 kilometers. Part 3. It is necessary to construct a large water tank on top of a concrete pillar to provide water to these 3 cities. In the above sketch, mark a suitable place where the tank can be built so that the lengths of the water pipes that carry water from the tank to each of the 3 cities is the same, and mark this location as T in the sketch. Now the distance from the tank to city C, city A and city B should be the same. So that means when you take a circumcircle, around city A, C and B. Circumcircle means all points on the circle. The center is the place where you have to keep the tank. So where is the center? This is a right angle triangle. In a right angle triangle, the circumcircle is, the center of the circumcircle is on the hypotenuse. So when you draw a perpendicular bisector, one perpendicular bisector, you can find out the center. So here, if you take CB is, we don't know the length, we know AC. AC is 38.3. So 38.3, when you draw the perpendicular bisector, that means straight away half of that. So 38.3 divided by 2, roughly 2 times 1, 2, 9, 2 times 1, 2 and 5, 19.15. So here from A, this is 19.15 kilometers. You can draw the perpendicular bisector. So where it cuts the AB hypotenuse, you get the center of the circumcircle. So this is the center. We see that these two lengths are equal. So what's the radius? If this is 50, the center to this point and this point equal means this is 25 kilometers. Here also 25 kilometers. So where you need to keep the tank T? Tank T should be here. That's the circumcenter. mark the location as T in the sketch. So you need to remember this is 25, 25. The midpoint of this one is the circumcenter. That's the tank T. Information on some of the students who were involved in a pageant in which 160 students participated is given below. So altogether how many students? 160. So this is outside number is 160. 1/4 of all those who participated in the pageant were involved in at least one of the three activities. So what it means? What's the outside number? So this is 1/4. So outside is 3/4. So what is 1/4 of 160? You get 40. So this whole thing is 40. This is 120. What are the three activities? Dancing, singing and playing an instrument. From the 16 students who were involved in playing an instrument and dancing, 6 students also sang. What it says here? From the 16 students who were involved in playing an instrument and dancing. Playing an instrument and dancing, that means this part, that's 16. Out of that, 6 students also sang. So 6 students also sang means this part is 6. So if you draw the diagram, a bigger diagram, so it says this is 6 here. Then another information now. This whole thing is 16. So what's this part? This is 10. So 10 plus 6, you get 16. Now it says this one. Twice the number of those who were involved in playing an instrument only was involved in singing and dancing only. So if this is only playing an instrument, if this is Y, what's 2Y? Involved in singing and dancing only. So not playing. So which part? This part. So this becomes 2Y. Then the other one, it says 5 times the number of those who were involved in playing an instrument only. Whereas playing an instrument only. And 5 times the number of those who were involved in playing an instrument only danced. That means only dancing. So only dancing is this part. That's 5 times this. So 5y. And copy the given Venn diagram in your exercise book and answer the following questions. Mark the given information accurately in the Venn diagram. So this is the diagram. Now we need to find out y. How can we find out y? We know that this is 120. All these regions equal to 40. So we'll add all together. That should be equal to 40. 5y plus 2y plus y plus 6 plus 10. That should be equal to 40 because 1/4 of the whole thing. 5, 2, 7, 8y equals 16 there. Take 16 out, subtract 16, you get 24. So y equals 24 divided by 8, that's 3. So this number is 3 now. So this is 3 So 3 times 2 here 6, 3 times 5 you get 15 here. So that's the correct diagram, and we need to answer these questions. How many students were involved in all 3 activities, singing, dancing and playing an instrument? Intersecting point of all 3, that's this part, that's 6. How many were involved in only playing an instrument? Only playing is this part, that's 3. Express the number that was involved in only one of these 3 activities as a fraction of the total number of students that participated. Only playing one thing. So here only playing an instrument is 3. Only dancing, that's 15. So this one we can't take. This is not only singing. Singing and dancing. So 15 plus 3. So 15 plus 3 out of 160. 18 divided by 160. You can divide by 2. That's 9 and 80. So 9 divided by 80 is the fraction. Part 4. Describe the activities in which the students in the set represented by S dash, singing dash with dancing and intersecting this one. So they are asking about this region. This region. So how many students belong to this set is 10. So how we describe this region? You can say students who are not singing. Here we identify from the question itself. It says students who were involved in playing an instrument and dancing but not singing. So from these not, so you are getting only this part. So we can write down students who were involved dancing but not singing. And this part as well, that's playing an instrument. So I can write students who were involved dancing and playing an instrument, playing an instrument but not singing. So these two but not singing. So that's 10 students. Question number 4. Identical balls of different colors have been placed in 2 vessels A and B. So 2 vessels are there, A, B. Vessel A has 3 black balls and 2 white balls. Vessel B, 2 black balls and 3 white balls. A person randomly draws out a ball from vessel A and places it in vessel B. So take one and places in vessel B. He then randomly draws out a ball from vessel B. Draw a tree diagram with the probabilities relevant to the above events marked on the branches. So we'll first draw taking a ball from A. How many colors? Black and white. Black, 3 blacks out of 5, 2 whites out of 5. That's A. Then what we do? We are taking a ball from B. But now the balls are increasing depending on the first trial. So taking a ball. This is black ball taken. So how many blacks are there now in the B vessel? 2 plus 1, 3. So altogether 5 were there now. 5 plus 1, 6. So 3 over 6. White ones already 3 were there. So 3 over 6. Now consider taking a white one and put it in vessel B. Black ones same as it is. So 2 over 6. But white ones 3 plus 1 becomes 4. So 4 over 6. So this is the tree diagram for taking a ball from A and put it in vessel B and then take another ball. Part 2. Using the tree diagram, find the probability of drawing out balls of the same color. So you can get either black black or white white. So we'll first find probability of getting black and black. So what's the probability of getting black and black? So you have to select correct paths. So here either this branch or this branch. So black and black, 3/5 multiplied by 3/6. 3 times 1, 3 times 2, you get 3 over 10. Now find out getting white and white. This branch, 2/5 into 4 over 6. 2 times 2, 2 times 3, you get 4 over 15. Now you have to add those two to get the same color. Probability of getting same color is 3 over 10 plus 4 over 15. What's the least common multiple? What's the common denominator? 10 and 15, that's 30. 3 times 3, 9. 2 times 4, 8. So what's the value? You are converting to the same denominator. 9 plus 8, you get 17 out of 30. So the probability is 17 out of 30. Question number 5. As indicated in the figure, AB is a diameter. So this is the center, passes through the center. The tangents EF tangent drawn to the circle at the point D is parallel to AB. Write down two angles which are equal to ABD. ABD. We'll draw it. You need to find out this angle. So what are the other angles equal to that one? So we have to write down two angles. Now look at these parallel lines. This angle and this angle both are equal because of alternate angles. So we can write one angle as BDF. Alternate angles. Now we need to find out another angle. What's the other angle? Now look at AD chord. So when you take AD chord, this is the angle in one segment. So that's equal to the angle in the same segment. Here, can you identify that one? DCA angle. So same segment angle. So what's the other angle? ACD. Same segment angles. Part 2. Find the magnitude of EDO. EDO. This one. What's the magnitude? This is the tangent and this is the radius drawn to that tangent point. So what's the angle? EDO is 90 degrees. This is perpendicular. So radius is perpendicular to the tangent at the point. Part 3. Show that OBCG, this one, is a cyclic quadrilateral. So we need to show that that's equal to opposite angles add up to 180. Now look at OBCG quadrilateral. We know that these two are parallel. So according to allied angles, this is also 90 degrees. So this angle plus this angle is 180. If this is 90, so this is 90. So we'll first write down DGB angle is 90 degrees because of allied angles. And the two lines are parallel. EF is parallel to AB. And what can you say about ACB angle? ACB angle is also 90 degrees. Say this is the angle in the semicircle. So because AB is the diameter, that's also 90. Angle in the semicircle. Then when you add these two, what you get? DGB plus ACB equals 180. So opposite angles are supplementary. So opposite angles are supplementary. That means 180. Therefore, OBCG is a cyclic quadrilateral. So that's the third part. Question number 6. That's the construction. Do the following constructions using a pair of compasses and a straight edge with millimeter centimeter scale and showing the construction lines clearly. Construct the triangle ABC such that AB is 8, B angle is 90 and BC is 4. So you have to create a right angle triangle. We'll take a straight line and then we have to mark a point B. AB length is 8. So take the ruler, measure 8 centimeters and using the compass you measure 8 centimeters. Then keep on top of point B and draw the arc. That's the point A. This is 8 centimeter line. Then B angle is 90 degrees. So we need to construct 90-degree angle. So how we do that? Keep the compass on top of point B. Draw an arc to this side and to this side. And take a different length. Keep on top of this point and draw the arc here. And keep on top of this point and draw the other arc. So the intersecting point, this one with B, we connect with a ruler. That's 90-degree angle. And it says BC is 4 centimeter. So we need to take 4 centimeter length from the ruler. With the compass, measure it. And then keep on top of point B and draw the arc. That's point C. Now connect A and C with the ruler. So that's ABC triangle. BC is 4 centimeters and AB is 8 centimeters. Second part, you need to construct the trapezium ABCD. That's CD is 2 and this is parallel to, CD is parallel to AB. Take the compass, we'll measure 2 centimeter length. We measure 2 centimeter length and keep on top of C point and draw an arc here. And here also it's easy when you take 2 centimeters here and draw an arc to get the 4 centimeter length. So we are using the property of a parallelogram. Opposite sides are equal. So we'll take the compass and measure 4 centimeters. And to this point we can draw, just mark the 4. We can take the point 2 centimeters away from that and draw the other arc. So the intersecting point of this one and this is the point D. Now take the ruler and connect C and D. So this is D point and you have to connect now AD line as well. Now this is the BADC trapezium or ABCD trapezium. This is 2 centimeters here and this is 4 and this is 8. Now the last part, construct the circle that externally touches CB produced. So we need the ruler and extend these lines. So extend this CB line and CA produced. So we need to produce that one as well. So we'll take this line and I'll take CA line and produced it. And then AB produced at F. Here there's a small mistake. When you do AB produced, you get this way. So here, can we draw a circle with all extended lines? We can't. So here, this is an error when translating Sinhala to English. This should be not AB produced, AB touches. Touches at F. Touches outside. So that means outside the triangle, it touches the line. That's F. So what's that? You are asking to draw a circle outside. Touches CA produced, CB produced and AB line. So how we draw that? That's the circle outside. You take the angle bisectors. Angle bisector of B and angle bisector of A. Intersecting point is the center of the circle. And how can we find out the radius? Radius, we have to draw a perpendicular line to one of the lines and take the radius. So we'll draw the circle outside the triangle. So we'll draw it. So take the compass. Take any distance from here. Take any distance. Draw arc here as well as arc here. Now we are trying to draw the angle bisector. Then what we do? Take the same length or different length and draw an arc in the middle. Here as well as with this point. Then what you do? We draw the line. So connect this one and this line, that's the angle bisector. Now we'll draw angle bisector of A. Take the compass again. Take any distance. Draw an arc here and here. So take another length and keep on top of A, not A, keep on top of this point and draw an arc and keep the compass here and draw the other arc. So the intersecting point and this A point we connect with the ruler. That's the angle bisector of A. Now this is the center of the circle. Now how can we find out the radius? Radius is the perpendicular bisector. So we'll take another color. I can take this perpendicular line as well. So I'll take blue color to draw the perpendicular bisector. Take the compass. From this point you can take any distance. And we need to draw an arc somewhere there. So I'll take further. Draw an arc here and arc somewhere there. So here we'll do it for the other point. Take the compass, we need to draw the perpendicular bisector here. So we'll keep the compass on top of O, take any distance, you take somewhere there. And we need more to find out any intersecting point with this. So we'll take this one. So we'll draw an arc here. So here, straight here on top of A, doesn't matter. And we need another arc here. So this point. And then we can reduce the length. Keep on top of this point, draw an arc here and keep on top of this point and draw the other arc. Now we can connect these 2 points, that's the perpendicular bisector. This point and this point. This point and this point. You connect it. So we get the perpendicular bisector here. Now we can take the radius here and draw the circle. So when you draw the circle, it touches the AB length, CB produced and CA produced. So here keep on top of O and now take the radius here and we can draw the circle. So I'll take red color. Now we'll try to draw that. So you are getting the circle touches AB and CA produced and CB produced. Now here we need to put the letters. What are the letters? It says CB produced at G. So where's G? CB produced at G. So this is G point. And CA produced at E. So this point is E. And AB touches outside at F. So here touches outside F means this is F. So you need to mark the points to get full marks. This is the last revision we did before your O-level exam. So make sure that you revise all the topics and all revision work and then at least 10 past papers before your exam, because time management is important in O-level exam. So make sure that you do short questions within 2 minutes and take like 10 minutes, 8 minutes for long questions. Take my advice, you can get a good grade in your O-level exams.